determine the eigenvalues of the matrix A, -4, 2, 2, -1. So in solving or finding the eigenvalues are determined by solving the characteristic matrix of the equation. So the eigenvalues are determined by solving the characteristic equation. So this is the characteristic equation. A matrix, for example, a matrix A, then you subtract the product of lambda and the identity matrix, so their determinant should be equated to 0. So the determinant of a matrix A minus the product of lambda and an identity matrix equals to 0. So if you are given a 2 by 2 matrix, like for this case, we're having a 2 by 2 matrix, what you do, you simply take your matrix, that is -4, 2, then 2, -1, then subtract product of lambda with an identity matrix 1, 0, 0, 1, then their determinant should be equal to 0. So for this case, you take lambda and multiply by each of these elements. We'll have -4, 2, 2, -1, then minus lambda 0, 0, lambda, then the determinant rather is equals to 0. So what you do here, you just subtract -4 minus lambda. So we'll have -4 minus lambda, then 2 minus 0, we have 2, then 2 minus 0 again here, we have 2, then -1 minus lambda. So for this case, the determinant of this should be equal to 0. So in getting the determinant, we always take the product of values in the leading diagonal, that is -4 minus lambda, multiply by -1 minus lambda, subtract the product of values in the other diagonal, that is 2 times 2, it should be equal to 0. So when you open the brackets here, we'll have -4, should be multiplied by everything here, so -4 into -1 minus lambda, then minus this lambda into -1 minus lambda, then subtract 2 by 2, which is 4, is equal to 0. Then what you do here, -4 times -1 is +4, -4 times negative lambda is +4 lambda, then -1 times -1 is positive lambda, then negative lambda times negative lambda is positive lambda squared, then -4 is equals to 0. So what you're supposed to do here is to rearrange and form a quadratic equation, then solve using the quadratic formula. So what we can do, you'll see lambda squared, then this 4 minus 4 is 0, then 4 lambda plus 4 lambda is +5 lambda, then is equals to 0. So in solving this, you can see that lambda is common, so I'll put lambda outside, into lambda plus 5 is equals to 0. Then the first solution will be lambda is equals to 0. Then the second one will be lambda plus 5 is equals to 0. So in the second one, if you take +5 across the equal sign, you'll be able to find that lambda will be equals to -5. So for our case, therefore, the eigen values are lambda is equals to 0, or you can just you can just say the values are 0 and -5. The eigenvalues are 0 and -5. Now I want you to try these 3 questions with that same idea. You need to know how to find the eigenvalues. I've slotted the answers here. So determine the eigenvalues and eigenvectors of the matrix. Then the matrix A is here, and you should get these solutions, then also get the eigenvectors, then the second matrix, then the eigenvalues and eigenvectors. Then you can also be given the same in 3 by 3, whereby you have the matrix here and you're supposed to get the eigenvalues. Now for 3 by 3, you'll get 3 values and also get 3 eigenvectors.